we we are going to learn AHP, Analytical Hierarchy Process. So what is the first step in AHP? The first step is to create the hierarchy. So the goal is, then you have to have criteria 1, criteria 2, up to number of criterias. Then you need to have option 1, option 2, option 3, and so on and so forth. So you can have multiple options, you can have multiple criteria. Based on multiple criterias, you are going to select best option. That is what is the goal. Let's say we are going to select a car based on 3 criterias. Criteria 1 is style, criteria 2 is reliability of the car, and criteria 3 is fuel economy. And you have different car options. Let's say you have Honda Civic, you have Saturn, you have, let's say, Escort, and here you have the 4th option, which is Miata. So these are the 4. Based on style, reliability, fuel economy, which is the best option, which is the second best option. So we are going to solve this. These are the multiple criterias. We are going to solve this problem. It could be much more bigger. So this is the hierarchy which has 2 layers, criterias and options. You can have criteria, you can have sub criterias, then you can have options. You can go more and more. So basically, this is a simple hierarchy. You can go 2 layer, 3 layer, 4 layer hierarchy. Now, based on that, we are going to make a pairwise comparison matrix. So here I'm just going to use style, style, reliability, reliability. And third thing, fuel, and fuel. So now we have a matrix, empty matrix has been created. So I'm just removing these things. Now, how do we put the numbers in this? So numbers can be collected based on the survey, based on the opinion, based on the judgment of experts. Let's say I'm giving a very simple example, which is out of this example. Let's say Spokane and Seattle. I think Seattle is approximately 1 million population, and Spokane County is around 500,000. So if we compare, we can fairly compare Spokane and Seattle. Seattle is 2 times bigger than spoken. Spoken is half of the size of Seattle. So, so this is the comparison between spoken in Seattle. Let me take their New York also, New York City. So if I compare New York City, what is the population? Approximately 10 million, if I count. You know, as compared to Seattle, New York is almost 10 times bigger. As compared to Spokane, New York is almost 20 times bigger. Now look, compare the Spokane with New York. How much? This is, so this is 20 times bigger. Then this is 1/20, which is, this is 20th part of New York, Spokane. So exactly the same method is used here in order to fill this matrix. Okay, so here, let's say I'm just going to create a three or four layer of, so one is known as neutral, one is known as equal, equal, equal weight or equal value or equal, means, for example, if I compare style to style, they are equally 100% equal. So one is considered is for equal. Now I go here 3 or go for 2, 3, 4, and 5. So this is a positive side. Let me go this way. Now I go here in this same way, 2, 3, 4, and 5. How do we collect the response? Let's say this is reliability and this is style. So the comparison between, so this is the survey questionnaire or this is the questionnaire. Now you ask this question from any expert or anyone, those who have the knowledge. How, what is your importance is in terms of, as compared to reliability to style or style to reliability? How do you compare these two things? Where you will put more importance? If I'm asking you, would you prefer reliability of the car or would you prefer style? You will say you you will give 3 times more weightage on reliability. So I can select this part. Okay. Then at the same time, that means you are saying your style is 1/3 of reliability. Means you give the preference 1/3 over reliability. So this is the, similarly we are going to put, so from row, so we are going to read this style over style, which is 100%. So now style to reliability, that means it is coming, style is preferred half of the reliability. So how am I going to put here? 1 divided by 2, and which automatically, style is 3 times higher preferred than fuel economy. So it is there. Now reliability over style, since it is style over reliability is half, then reliability over style is twice. Reliability to reliability is 1. Reliability to fuel economy, 4 times higher reliability is considered or has importance than fuel economy based on the observation or survey or any opinion. Here fuel economy over style is 1/3 is preferred, because here style fuel economy, here style is 3 times preferred, then It is exactly opposite. Now here, fuel economy to reliability. As you can see, this is reliability to fuel economy is 4 times. Then similarly, it is 1 divided by 4. And now the last, which is fuel economy to fuel economy, is 1. So this is your pairwise matrix is completed. Once you complete this matrix, the next thing is that you are going to take sum of the column, entire column, sum of entire column. We are going to do the normalization. So I just do it sum. Similarly, I just need to drag and I get the sum of this thing. What I'm going to do now, here you can see, I'm just going to take this. So this is the sum. Now I'm going to generalize this matrix. So this is the sum of the entire column. We are going to divide this value from this, from each of them. So this is the value divided by sum of the column. Here, this is the value divided by sum of the column. This is the value. This is the value divided by sum of the column. Similarly, we are going to do for this, divided by so this is also generalized. Now we are going to generalize fuel economy column. So this is the original pairwise matrix. Now we have normalized pairwise matrix. Now, how I can check why this normalization is done correctly? Let me see if I get the sum. If all the sum is 1, then our normalization is correct. And now we can see the normalization is correct. What is the third step? Third step is to take average of row. So I'm just going to take average, and now I just drag. And then so this is the average. So now you got, this is style, reliability. So what is the weight of each criteria here? Or this is also called it priority vector. Oh, sorry. This is also called priority vector. So style is having 32% priority, reliability is 55, fuel economy is 12. Let's round up to this in order to make it. So this is, let's say 30, this is say 60, and this is to make it easy calculation. So this is the priority. Reliability is 60%, style is, and this is 1. Now we would like to check whatever calculation we have done, it is consistent. For that purpose, we have to do consistency ratio. To do a consistency ratio, so hope you are able to understand till here. Now I'm going to take this table again, this matrix again, and going to perform consistency ratio. Okay, so this is our original table. What is the value of here of this style is 30%, so I put here 30%. Reliability is 60%, and fuel economy is 1. Okay, what we are going to do, we are going to multiply this every individual every value here with 0.30 zero 0.3. This we are going to multiply with entire column values, we are going to multiply with 0.6. We are going to multiply with 0.6, and then this one is we are going to multiply with 0.1. Okay, let me do this. So the new matrix will be, I'm just going to copy here again. It would be easy. Now, okay, this multiplied with this. Okay, here we go. This multiplied with, I'm doing one by one so that you can understand properly. There are, functions which does this task very easily in Excel. Okay, so 0.5 multiplied with 0.6, 1 multiplied with 0.6, and 0.25 multiplied with 0.6. So we have done 2 of them. Now third, 3 multiplied with this, 4 multiplied with this, 1 multiplied with 0.01. So this is the why we are doing, because we are just going to calculate lambda max. For lambda max, this is the process of doing. So we have a weight of each criteria, then we are going to multiply in each column, and now we are going to do sum. In earlier situation, when we calculated the criteria priority vector, we did the average. Now here we are going to do sum of row, which is, now I just, so this is what we got. Now the third thing, our priority vector are here 0.3, 0.6, and 0.1. So what we are going to do, we are going to do, this is, I'm not going in the terminology of matrix, we are going to divide this by this. So equals, sorry, here to calculate lambda max, we need to equal to this divided by this. And similarly, we are going to do this. And then we take the average of this entire column. This value is going to be lambda max. So this is our lambda max. Now we have to calculate consistency index, CI. The formula of CI equal to lambda max minus n divided by n minus 1, and this is the formula. So we are going to put the values. N means how many criterias are there. So which is, we have 3 criteria only. So we got this and this. So now I'm going to calculate, which is this minus n, which is 3, divided by 3 minus 1. So this is our CI, or you can say consistency index. And now consistency ratio formula equal to CI and index. So this index is given in the slide, and this index, so let me show you in the slide part. This is called consistency ratio. For example, this is 1 factor. There's no weight. For 2 factor, there's no value for that. 3 factor, we have this value 0.58. So this is the index directly taken from the author, the pioneer of this method, Sati, from his book. So 5 factor, this. So you can see all the factors in their index. So CR equal to CI and divided by index. So what is this? CI is this divided by, for 3 factors is 0.58. Now we got our CR, which is consistency ratio. Consistency ratio is how much here? 4.7%, or in roughly you can say consistency ratio is 5%. Or I can say approximately. So approximately 5%. Now the rule is there, and if consistency ratio is less than 10%, what is? It should be, if less than 10%, we can, what we can predict, what we can conclude here, that we can conclude that our evaluations are consistent. So since this is 4.7 or 5% is less than 10, so whatever weightage we have achieved here for style, reliability, fuel economy are consistent. So this evolution is consistent. So we got the first thing. We have target here to choose the car. Now we got the value of style is 0.3%. Style is 0.3. Reliability is 0.6. And fuel economy is 0.1. So this is the weighting criteria, weight of each criteria. Now similarly we do for next level. So this is first level we have done. Now we go for all the cars. We have 4 options of the cars. So what we do, we are going to check the style. And based on style, we are going to compare all the options. Like we have Civic, we have Saturn, Escort, and similarly we are going to put here oh, oh. The comparison is based on style of each model. and there Civic, Saturn, Escort, and Mia. Okay, based on style, Civic to Civic is 1. Civic to Saturn is preferred 1/4. Civic to Escort is preferred 4 times. Civic to Miata is preferred 1/6. Similarly, here since Saturn, here this is preferred 1/4 times, then automatically this is preferred 4 times. Then Saturn to Saturn 100%. Saturn to Escort is preferred 4 times. Saturn to Miata is preferred 1/4. Escort to Civic is preferred in terms of style 1/4, 1/4, 1, and let's say this is 1/5. So what is important? Important is, if you are going to put here 20, 1/4, then certainly you are going to put here 4. Never make any mistake putting these. Let's say you are putting here 0.2 and here you are putting 3, which is not correct. Here you need to have 1/3 then. So this is very important. So observation, when you do, you must check this matrix, because this is the beginning point of putting this based on the survey, based on the expert opinion, or expert advice. These numbers are very important. Means equally important, reciprocal values must be there in opposite opposite block or opposite box. So this is very important here. Let's say Miata is, so here it was preferred, Civic preferred 1/6. Civic preferred 1/6 over Miata. Then Miata is preferred over Civic 6 times. Similarly, Miata is preferred 4 times over Saturn, because here you can say Saturn is here and Miata is this. It is preferred 1/4. Now here this is 4th times. Escort, here Escort is preferred 0.2, which is, this is 1/5 times preferred here. So this is going to be 5 times. And now because this is the matrix. Now again, we are going to do the exactly same procedure that we did. We are going to take sum of the column. After sum of the column, exactly, we are going to take sum of the column. We are going to divide this in each value of this. So we are going to normalize these values. So I'm just going to show you normalization of this. Okay, here now I just copy this in order to normalize this. So what we are going to do is this divided by this. This divided by this. This divided by this. So hope you can see Now I need to check whether this is correct. So I need to check the sum, and it should be 1. Similarly, if we do for this, for this, for this, so let me do it quickly. Oh, sorry. Divided by this. Now I need to check whether this is done correctly. Okay, correct. This divided by divided by divided by. So I'm making it one by one so that you can have clear understanding. Otherwise, there are options under Excel to do this in one sort. Oh, now I just do. So automatically when I will finish, you will get the divided by 1. So you got this. So this matrix means all the options are compared in pairwise for style only. And now we are going to take average. So I just put average formula here. And now I check, sorry, sum. Or I can just, instead of this, I can. And here you get 1. So what is the value of this? Civic is 13% over style in style. So you can say just 13. So I can take this. So these are the weightage of Civic. This is 24%. This is, you can say, approximately 70%. This is 56%. So you can round up. So these are the values. So now we got these values, and that you can put here under style. I think, yeah. So basically this is, oh, yeah, I need to do with $sign. No problem. So I can do here. So yeah, so basically you can have civic value in terms of style, certain value in terms of style. This is, you can say, 13%, 0.13, 0.24, point, how much? Approximately 7%. 0.7. Yeah, I'm just doing something. I did. So basically this is 0.07, and the last one is 0.56. So these are, similarly you can do, you can create this matrix for, you can create this matrix for reliability, and you can create similar matrix, and you can get the weightage for, or for fuel economy. Even fuel economy you don't need to do, because you have the clear number and you can get the values. So when fuel economy, you know what is the mileage of Civic, what is the mileage of uh, so using the proper mileage, you can normalize those values and you can get to know the real values of each of them. So let's say, so reliability is 0.38. I'm just using slides example here. This is 0.29, 0.07, and 0.26 based on reliability. Similarly, based on fuel economy, I just so Civic gives 34, 27, 24, 28. So let me go for fuel economy. 34, 27. This is actual fuel economy that you can get from 24 and 28. This is the actual for Civic Saturn. Let me calculate the total sum. When you have actual numbers, you can compare this, which is 113. So I just divided by 113. 27 divided by 113 to normalize these values. 24 divided by 113. 28 divided by 113. So these are the values of, these are the normalized value of fuel economy. So now I'm just going to put these right here, which is 0.3, 0.24, 0.21, 0.3, 0.24, 0.21, and 0.25. So now you have criteria and their weight. Now you have comparative, pairwise comparison of all four options in style, reliability, and economy. Now you are there to make final decision. Why? So for example, now this is Civic. Now first thing is Civic. So let me go with Civic. What is the weight total value of Civic? Civic, sorry, equal to 0.3 is style weight multiplied with this plus 0.6 is the reliability weight multiplied with reliability plus fuel economy is 0.1 multiplied with fuel economy value. What is the total weight of Civic is point this. Similarly, for Saturn, I mean, you can calculate. I'm just going to put the numbers. Saturn, Escort, and the fourth option is, and so this is 0.27. If you calculate again, this multiplied with this plus this multiplied with this plus this multiplied with this, altogether is this much. Escort is 0.8 and then 35. 0.8 and 0.35, and this you can round up to 30%, 0.3. So this is the final decision matrix. Now, based on your four criterias and three criterias and four options, which option is having highest value? This is the first option. You need 35% is Miata. The second is Civic. So if you suppose you want to rank the cars uh, from four of them, which one? This is going to be the number one. This is going to be number two choice. This is going to be number three. And the last choice is this. So you can also rank the options. Similarly, if you are going to uh, procure some item from any vendor, how you can select the vendor, how you can give the vendor rating. Number one is this, number two, based on certain criterias. So this has emerged number one, this is two, three, four. So this is what is called analytical hierarchy process. There's a, another method based on that, that is called analytical network process, ANP. We are not going to learn that because this is already for those who don't have any mathematics or that background, it is going to be a little bit again complicated because we have to go through many matrix, pairwise matrix consideration. So this is very simple and it can be used in many situations. Thank you.